Hello everyone, and thank you very much for joining this live event, which is lesson 46 from the Java Fundamentals stream, and we are going to discuss about threads. Well, we actually started our discussion about threads in the previous lesson, and you've seen how you can use the thread class to create the simplest thread, and we've also discussed about the thread lifecycle, and now we are going to continue with the runnable interface and more methods from the thread class. And depending on how fast things work, we might even discuss about synchronized and so on. If not, we will of course continue with that in the next lesson. So let's start with working on the first example. Well, if you are watching the event live, don't forget that you have a live chat there, and I always have an eye on the live chat. And if you are watching the event recorded, you can still ask questions in the comment section, or you can simply find me on LinkedIn or Twitter and you can ask me the questions there. So I will switch you now to my computer, and you will actually see that I have already created here just a normal empty project using Java 14 as usual. Well, as usual, like in the latest Java version we have at the moment. And we will start with our first example where I simply want to show you what the runnable interface is and how you use it, and then discuss a little bit on why should we actually use interfaces like runnable, and you will see further in other next examples callable, another very similar nice interface, thread related, instead of actually working directly with the thread class, because in the previous lesson when we started we have directly discussed about the thread class and working with the thread class, but as you will see, actually in most of the cases you would rather use the interfaces for decoupling and implementing not only functional application but also easier to maintain one. So that's why in general you will see that using the interface to decouple the functionality is the best choice you can use in your implementations. Well, when it goes to the Java, to the actually OCP 11 or OCP 8 or whatever OCP exam, well, you actually have to know and have to remember also how simply extending thread class works, because you will see those kinds of examples as well. But in general, in a real world example, do choose to use the implementation of runnable over extending the thread class. So I bet you still remember how we extended the thread class and created a thread in the previous lessons. So I will start with creating a very simple example where instead of this time extending the thread class, I will implement the runnable interface. And the runnable interface is a very simple interface having only one method, which is called run. And the reason why it's called run, because this already might sound familiar to you, is actually the same name of the method we have overridden when using the thread class. And that's because it's basically the same thing. We override the run in this case for the same purpose, that's to define the main method of the thread. So we actually say what will be executed as part of the set of instructions of that thread, which again it's a set of instructions which work independently from other instructions of the same program. So say I would like to actually print the odd numbers, let's say the first odd numbers is just a similar example to the one we've worked on in the previous lesson, but instead of extending the thread class, I will implement the runnable interface. Then I would actually create a class, and let's call this odd numbers runnable, and I will end the name of the class with runnable just because, yes, I would like actually here to create a runnable which is a task. So this object, once I finish it, I will be able, as for any other object, to create instances by calling its constructor. But the difference is that now only by creating an instance of this object I won't create a thread object anymore. In the previous lesson, when I was actually extending the thread class by inheritance, so by extending thread class, I was actually creating a more particular type of thread where I was overriding the run method and implementing the instructions. But because here I actually do implement runnable, so I don't extend thread. Well, in this case, my object isn't a thread. So I don't expect this to act as a thread. I will still have to use the thread class and transform this task into a thread. So specify somehow that this task will be executed independently to other instructions in my same program. That's in, again, this case I will implement the runnable interface, and the runnable interface fortunately is a contract with only one method, the run method, so I have to override run in this case. And in case of actually implementing Runnable, you really have to override run, because being an interface and the method inside it being abstract, I have to mention that because, as you know, starting with Java 8, you can actually have methods that are not abstract in interfaces. When I was teaching these lessons some more years ago, when Java 8 wasn't there yet, well, I didn't have to specify that because you didn't have any possibility to actually have default methods in interfaces, but now you know you can. So for already more than 6 years we have this feature in Java, so I have to mention it. A runnable interface didn't change. That means that its own method, its only method remained abstract, so you really need to override it. I specify this explicitly also because a lot of times in the OCP exams I've seen, I have encountered questions where I don't know for which reason they wanted to test the fact that you know that the thread class is not abstract and it doesn't have abstract methods. So then if you extend the thread class, you are not it's not mandatory that you override the run. You can actually create a you can actually extend the thread class and override the no method, which means that you can simply just extend the thread class and that's it. It's not abstract, it's just a thread that does nothing, but you can do that. So syntactically speaking, you will have no compilation error. But of course, if you will try to implement the runnable interface and you don't override the run method, then you will have a compilation error because you can't have a non-abstract class that implements and inherits an abstract method and doesn't of course override it to offer it an implementation. So in that case you'd rather have the class abstract if you'd like it to compile. But yeah, I don't know, that's only some syntactical things that you know from the very first lessons of this stream, so I won't get into more details with that. I wanted just to grab your attention a little bit on this aspect whenever you will maybe at some point you encountered some questions like this in your OCP exam. So now, of course, being that I have this runnable, I define my task, and the task starts from the run method, which is the main method of the task, which means that if I would like to print the odd numbers starting from 1, I can do it something like this. Let's say I start from 1, and then let's say I only print out the numbers up to 11, and to only print the odd numbers, then I will print it, I will be adding 2 to each of the numbers. So that's the system out, and I print I, and besides I will also print the name of the thread. And you remember that in order to refer to the current thread that's executing my instruction, I can always from the thread class use the current thread static method, and the current thread static method representing the thread, then I can actually use its get name method to get the name of the current thread, and we've used it also in the previous lesson. You know that even if we don't provide a name to a thread, the JVM will actually give a name to that thread, so we can print it out only to see that's a different thread from others that we will run, so to use it in our debugging learning purposes here. And this is it basically. With that, I already have a task, but I can use this task and I can execute it as is on the same thread, and I can decide to put it on a separate thread. So let's say that I decide and I need to actually use it on a separate thread. So in this case I declare an T1, which is actually my task. Maybe it would be actually better to call it R1, like runnable one, because if it's T1 maybe you will think about thread, and I don't want that because this is actually not a thread. So odd numbers runnable, and by this I have declared my task, and then now I have to put it on a separate thread by using the thread class. and in some of the future lessons you will learn also some more elegant ways of doing that by using, for example, executors and the executor services. But that's part of the high-level frameworks regarding threads we'll discuss in the next lesson. So we are still a little bit basic now with only discussing about thread and everything else. So I will actually create now a T1, which is really my thread, and I will use, as you've learned in the previous lesson, the thread class. But as you see here, the difference is that I instantiated directly. So in the previous lesson, you've seen me using the thread class, but in that lesson, I have actually extended the thread class. Now I didn't extend the thread class, I'm actually just creating an instance, and now one of the easiest way to specify this thread is going to execute the run method of the odd numbers runnable as part of its instructions. Is simply give it as a parameter to the constructor like you see here, and the thread class actually has more constructors. One of them is the one taking a runnable as a parameter, which is the task it's executing, and some others also can be used to provide a name to the thread as well. So actually something like this, if you would really, oops, my fault here, if you'd really like to give a name to your thread, well, actually the other way around, sorry. So you have a runnable and then you have the name of the thread. So yeah, we can actually call it T1 or something like that. But again, if you didn't specify yourself a name of your thread, then it will take a name by default that will be provided at its execution. So yeah, and again, if I just create a thread and I never start it, that's a thread which is at this moment, if you remember from our previous lesson, in the state called new. So following its life cycle, when I simply create the instance of the thread, it's called new. It's an instance of an object. You can use it. It occupies memory. If it doesn't have any more references, it will be grabbed out by the garbage collector, so it simply works as a normal object. But if you didn't start the thread, then you have no executing instructions. So now, of course, in order to really see my instructions executing, then I really have to call the start method. And again, make sure that you remember, when you want to start a thread, you call the start method, not the run method. If you call the run method, then it will actually work, but it will execute what's on that thread in the current thread, which is in our case the main thread. So you won't actually have multiple threads in your application if you call start and if you call run and you don't call start. So remember that start is actually the method that moves your thread from new to runnable, so to that state in its life cycle where JVM can take it and can execute its instructions. So now, of course, that you did so, you will basically see when running my program that the numbers appear in the console. And if I would print something at the very end here, you do remember from our discussion from our previous lesson that actually whatever we would print here can be printed before, somewhere in the middle, or even after, so it has more execution histories. And you can see that indeed this was my T1 thread executing, and indeed numbers from 1 to 11, odd numbers from 1 to 11 have been printed out in my console. And let's also, just to complete the example, print an end here, and again together with it print the current thread name in order to prove that the current thread on which the system out printing end is executing is the main thread, because the main thread is starting with the main method and is the default first thread of any Java application. So that means that end most probably will be printed on top of everything, but that doesn't mean it's not possible that it will actually print out somewhere else. It's being that's in parallel. We have all the possibilities, so it can print before everything from the other thread, but it can also print at the end or somewhere in between the numbers. You can see basically that I have two different threads. One is the main thread and the other one is the second thread I have created. And you see again the difference in implementation. Well, if you take a look at a first glance, it might seem that it's more difficult. It's a more difficult way. You actually, instead of having one class, you now have to create a class and then also use the thread class, so it might make no sense. Why is this better? But in a real world scenario where you have a more complex scenario, more complex class design, then it's always better that you use interfaces to decouple the implementations. So that's why using Runnable is a better approach, and you will find it with more complex than, of course, this very basic example. You will find it that it actually allows you more flexibility and makes your application more maintainable. So in general, do think of threads in terms of having the thread mechanism, and you know that's implemented by the thread class, and you will also learn more than that. You will also learn some high-level frameworks in the next lessons, like for example executor services or fork join. But again, that's for the future. The idea is always think in these two different pieces of the different components of your applications. So you have the tasks, and the tasks are represented by the Runnable contract, and you have the thread class, which implements the mechanism itself. So you see, I don't have to actually extend the thread class anymore. I do only implement my Runnable, and then I can instantiate the thread class, and I can specify that I want this task to be executed. Okay, and that's to clarify the way of working with the Runnable. So again, now think about it again. You can actually reuse the same task, and you can, for example, create a second thread. So if you'd like to have two threads of the same kind, then I can have a T1 and a T2, and then I can actually have the same instance here that I use. So I can have the same task again executed by a different thread, or I can even create a second instance of the same task, which sometimes matters, the way you will see further when we discuss problems related to multi-threading architectures like race condition or deadlocks. It might matter if it is the same task or if there are different tasks, but in this case, because the only thing we are doing is printing out some numbers in the console, it doesn't make so much of a difference anymore. So I can have, for example, the same task executed by two different threads, and I start these threads and then I do execute them. And again, being that I only print some numbers, which is a very simple task, you might see, well, I should have actually given it a different name, isn't it? So yeah, now it will print with T1 all over, but it's not T1 all over. It was just my fault because I didn't change the name of the thread. So you will see that there are two different threads, but because I only print some numbers, you might also see that they are printed again one after the other. So this is not my case here. See, sometimes it really is that they are interlaced from the beginning, but if you have a faster computer, I bet you will actually see this like one after the other, like only T1s and then only T2s. So in my case, yeah, my computer is not so fast, and I'm also having this all this software open here for the video conference, and that's why probably my application has a lot smaller capacity to work with in terms of memory and processing power. And you already see that these simple threads are interlacing, and you see that indeed they are two different threads. But if you are running it on your computer, do that without having too many software open and so on. You might see that actually most of the times you will basically see the T1s and only the T2s, and that might trigger you that you didn't do something right. But that's only because if your computer is fast and it's not occupied with a lot of other tasks, doing some printing out in the console is basically so fast that usually this thread manages to finish everything just before this other thread manages to start. So that's why you see them not in parallel like you see in my case here, which is again fortunately because I have my computer occupied with a lot of other tasks. But you will actually see them one after the other, but that's not your fault, is because both of the ways of displaying they are right, because you have threads, they are running in parallel. So remember our discussion from the previous lesson, you can't without synchronizing them or doing something special, if you simply start them, you can't be sure which will be actually the history it takes. So it only has to respect the rule where on the same thread, of course, the instructions always have to be in the order you have defined them. But when you discuss about two different threads running in parallel, then it's actually you can't decide, you can't know from the beginning how will this work. And in a real world scenario, you always need to make sure that all the scenarios lead to the desired result, because if you have at least one, believe me, is the Murphy's rule that when you have one case that doesn't fit and that's a bug, that one will be the one that happens only in production. So it instead of happening in test, it won't happen in test, you won't find it, and it will happen in production where it's the most difficult to find it and solve it. So make sure from the beginning that you take into consideration absolutely all the possible scenarios. Okay, that's with the simplest approach, and now I would like actually to discuss about some methods from the thread class. And remember, you have actually seen already the sleep method, which is a way to block the thread for a determined time. So we use the sleep method just to block the current thread. Sleep is a static method, and when you call it, it will block the current thread for the defined time. You define the time by the parameters of the method, usually by using the method which takes the milliseconds. You also have an overloaded version that takes nanoseconds, but that's much less used in real world scenarios. But you also have some more methods out there that are basic. I don't want to discuss with you all the methods because they are not that important, all of them, but some of them really are important, and some of them we also use with synchronization as well. So that's what I want to discuss now. So let me start the second example, and in the second example I would actually want to create a small scenario to prove the way join works. Join is one of the fundamentals method of the thread class, and one of the methods you might also use it if you work with threads low level, as I do here in a real world example. I know that doesn't happen so often nowadays. I've said that also in the previous lesson, but if you do encounter such a situation, join is one of the methods that you will encounter. Really, yeah, it's really possible to encounter, like much more often than even thread sleep. Thread sleep is actually not that often encountered in real world scenarios. It's more a lot in examples and theoretical problems, but not necessarily in real world examples. While join is actually the directly way in which you can specify that a thread must wait after another finishes. So that's why let's say the first way of synchronization that I teach you is not by using the synchronized keyword that I also want to discuss, but using the join method, which is a method of the thread class that specifies when a thread should wait after some other finishes. So let's take one example for that in a separate package in my case. So example 2 here. And in example 2, I would assume the following scenario. Let's say we need to grab data from two databases. We don't work with any database here, just to make it clear. It's only a very simple example, but you can imagine that. So do imagine that we have a system and we need to read data from two different sources. To make it easy for you to imagine, let's just say we are just querying two different databases. So we need to take the data from the two different databases, and then we use that data to do some processing, and yeah, that's it. At the end, everything finishes. Now, the idea is the following. Say that, and I will create example 2. Maybe using some comments here would be even more easier for me to say what I'm to clarify the scenario. So say that when you do query DB1, which is my first database, and you query the database 2, which is the second database, and then you do the processing, you don't actually care. You care that the querying of data is always the first that happens, because you need the data for processing, and that's the second thing that should happen. But when you query that data, you don't actually care if it is the first database or the second database. The order in which you grab the data from the database is not important, because in the end, when you go to the processing, then you simply need to have all the data. So it doesn't really matter in which order you take them. And say further that this actually takes 3 seconds. So in order to take the data from DB1, in your case, the functionality you have, it takes about 3 seconds, and then you have another, the second database, which is 2 seconds. So each of the databases actually take a few seconds to obtain, to query. And then once you've collected the data, you can start the processing. Okay, this is the scenario. So what we wonder here is how can we implement that? So the first approach and the easiest one is to put them on the same thread. If you do put them on the same thread, then it's no matter in which order you will grab the data, if it will be the DB1 or DB2 first, you will basically at some point have spent 3 plus 2, so about 5 seconds, and then you can start the processing. And then you think a little bit more. Could I actually change something, knowing that the querying is completely independent, as I've said in the scenario? Can I actually change something so that I spend less time with my entire program? Well, yes, you can do something actually. If you, instead of querying them one after the other, you would basically query them all together. Then instead of having the times added, you will actually have in general the about max time from the two, which is in our case 3 seconds. So you see 3 seconds is smaller than 5. So in my example, this means that if I put those two together on different threads, then I might have a chance to spare a couple of seconds, so to improve the time of execution. So let's say that's a good choice, and I would like to apply this now, because I found this choice. I would like to apply it now for my scenario and make this with threads. What else should I take into consideration before diving into my scenario? Well, of course, I have to make sure that the processing doesn't start before querying the databases, because if I do actually start the processing, if I do actually put this on different threads, and then the processing remains on the third thread, then that means that all three are completely in parallel now. So when I will actually start DB1 and DB2 querying on those different threads, then the processing will start at the same time, and I can't start the processing because I don't have the data yet. So what else should I do? Yeah, of course I have to make really sure that the processing only starts once both my DB1 thread and DB2 querying thread have ended, so once they have actually returned data. And that's what we are actually doing with, or one of the ways of doing that is the join method from the thread class, and that's what I'm trying to show you now in this example with this very let's say theoretical scenario, but that I've tried to make it a little bit more visual for you, so that you can not necessarily only look on a very theoretical example, but you can actually think in terms of something that can become practical. And this can become practical. It's still theoretical, but it can become practical in some situations. So let's see how can we actually implement that. Well, we'll basically create two tasks. I will create the runnable task, which refers to querying the first DB, and I will simulate its, let's say simulate the fact that it takes 3 seconds by using the sleep method, which you know from the previous lesson. We use that to block our thread for a defined time in seconds. So I will name this db1 runnable. So this is the task which queries the first database. I do implement the runnable interface here. I do override the run method, and then I call thread sleep of 3000 or whatever that was. And you remember that sleep, and in general do remember it's a general rule. There are very few exceptions to this rule. I will teach you the exceptions as well when it comes to that, but there are very few exceptions. Generally, whenever you see a method that refers to blocking a thread, remember that method throws interrupted exception. So the reason this doesn't compile here, if you go above the method, you will see that the error is unhandled exception, interrupted exception. So just remember this rule, because not for a real world example, because in a real world scenario you are typing on your IDE and you see that, but when you are going to the OCP exam, it's a very simple rule to never miss a question for this case. Remember that sleep, wait, any kind of join, you will see join as well, and any kind of other blocking methods that are defined in blocking objects we'll discuss, they throw interrupted exception. Interrupted exception, it is a checked exception. That means you need to add a try catch or throw it depending on the case. But you have to do something about it, because if you don't do something, then the compiler won't allow you to compile the application, so you have a compilation error if you don't treat this exception, like any other checked exception as well. So that's why you do have to remember that whenever you see a method blocking a thread, that throws interrupted exception. And to recap, interrupted exception refers to that case in which somebody would actually stop a thread while it's blocked. Remember that killing a thread while it's blocked is something considered exceptional and is not allowed by the JVM. So whenever something like that happens, your code will throw an interrupted exception. That's the meaning of interrupted exception. So that's why I do actually add a catch here, and I treat interrupted exception like, yeah, I only do print stack trace, but actually I have to at least add the try catch here because I have no other chance. So then I system out and I say db1 querying ended. Just I see a message, so I make sure that when this task ends, I will see a message in the console. And then I actually want to do basically the same thing. I will copy paste this task. So let's copy it, let's paste it. This is db2 runnable, and it's basically more or less the same thing, but I have only 2 seconds and I print out db2 here. So very simple. And now I'm going back to example 2. And what I'd like to do here is actually down below my comments create some threads for my tasks. So I have a var db1, which is new db1 runnable, and then I have a var db2, which is new db2 runnable, and then I have, of course, I do need to create the threads. So I do use the thread class to create instances of the threads for db1 and db2. So I create the 2 instances, and then I of course need to start them. And in the first case, this I consider then my processing starts immediately after running my threads. So I do start this thread, I do start this other thread, and then I system out here processing. So what do you think would actually happen when I start now this application? Where if I do start this application, what happens is that now I actually have three different threads in my application. So one of them is T1, which is dealing with the querying the database one, and one of them is T2, which is actually dealing with querying DB2. And then the third one is the main thread, which is actually the one representing, in my case, processing. And that's not quite good, because what you will see most probably when I run now this example is that the processing may start, and it's actually really probable to start, in most of the cases, before querying the databases, which is against our example, So I have a question. So is multi-threading concept used in I/O programming and reactive programming? Yes, it is. Now, depending, in I/O programming, we refer to input and output, and we will also deal with that. I didn't get yet to that chapter, but we will discuss about the Java I/O and Java NIO packages and implementations. You will see that in different situations you'd prefer to actually do that communication via streams, via I/O streams, to be more precise, using threads. And in one of the next lessons I will actually I'm not sure how soon will that be, but once we discuss about the streams, I/O streams as well, I will even create an application where, using sockets, which is low-level networking, you do communication between applications, and that's where I will have to use threads. So yes, in a lot of low-level architectures, if you do manage low-level your I/O streams, you might use threads. Then reactive programming, again, yes, reactive programming is a concept when having tasks, they are consumed and executed by different threads. Well, it's more than that, actually, more than I can say in a few words, but reactive programming, being that it will actually be one of the things I will use from some examples when I get to the executor services, and that's where I will explain them a little bit more. Reactive programming is kind of multi-threading architecture that in some situation we might use to enhance the way our application works by consuming inputs as tasks on different threads. So both of them, and especially reactive programming, are related with threads. I hope this answers your question, and I hope that also the next lessons where we will deal with some of them will actually answer even more out of that question with practical examples that we will do. Okay, cool. So we have, again, going back now to our example, so we have the threads here, and I want to start it to prove what I was saying. So the fact that this actually doesn't work as expected, because the processing might start before databases are queried. And you see that in my case, yeah, it really happens. So the processing was first, and then DB1 and DB2 have been queried, which is not fine, because you can't start the processing if you don't have the data. So in our case, the querying of the data is really important to happen before processing. So how can we make sure that a thread waits for other threads to happen, to end their work? So that's what I say. Synchronization in general as a term refers to controlling the execution of threads in terms of controlling the way they execute one relative to the other. And we will discuss a lot about synchronization, because there's almost no architecture about multi-threaded architecture without something synchronized. You need somehow to synchronize. It's not always just you put some threads going in parallel and that's it, now it's fine and everything is working fine. No, you have to control them. You have sometimes to say that one of them should start after some other ends. You have sometimes you need sometimes a way to say that a specific block of code is executed only by one thread at a time, and that's what we'll do by synchronization, and so on and so forth. So you need to actually control them somehow. And remember what I've told you in the previous lesson is that controlling threads cannot be done while you are in between the runnable and running states. when we discussed in the previous lesson the thread lifecycle, and do remember that diagram is really important, that new, runnable, running, blocked, dead states in the diagram. You really need to know that, and you really need to have it into your mind all the time. So you can't control the thread while it's in between running and runnable. And some will tell you that this is actually possible, and I want actually to tell you something related to that as well. You have a set priority here method. Maybe it's a great time to also have this set priority into consideration. This set priority is a method related to any thread that specify a value where you can actually specify a value from 1 to 10, referring to the priority, so how important is from your point of view that thread. And the legend says that the JVM will actually take that into consideration and will execute the thread based on the priority you give. While that might sometimes be the case, in a lot of situations, do remember that the priority is only an advice you give to the JVM. It's not something that if you said this thread really has the highest ever priority, then the JVM will actually really execute that with the highest priority, and it's not a way to control the threads. So what you do need to remember about set priority, the following things. Do remember that set priority is part of the OCP exam. Even if it's OCP 8 or OCP 11, you will find you might find questions about set priority. You need to know that the priorities are between 1 and 10. You need to know that the default priority is 5, and you need to know that theoretically you can set a priority to a thread. And the fifth and the most important thing, you must remember not to use it in real world scenarios. So do remember it only for theoretical cases, never use it from my point of view in a real world scenario. So don't trust set priority. If you need to control threads, controlling threads is done through synchronization, not using set priority. So even though if this set priority is actually a method you will find in your OCP exam, and I do recommend you to remember all those 4 things I've told you now, because they are things related to the possible question you might find in your exam. Do remember that in real world scenario, avoid that and use synchronization wherever you really need to control threads. So in my case here, what should I do is actually control my main thread, and once I've started T1 and T2, make sure somehow that the main thread, in my case representing the processing, will not continue if the other 2 threads, the ones that are querying the database, won't finish. So how can I do that? Using the join method. So join method, you actually have seen, you have more implementation of the join, maybe it was better to show you. So you have the join method which has no parameter. This join method will actually block the current thread indefinitely after it's called, so that the current thread waits for the thread you refer the method from, T1 in my case. So that means on line 23 the main thread will wait for T1 to finish and will forever wait for T1 to finish. And if you use again that one with no parameters, means it will actually stop here and wait for T1 forever. You have as well the possibility to specify a time as parameters, either by specifying only the milliseconds or only by specifying the millis and the nanos. See, the signature is very similar to the one you've seen for the sleep method, where you have the same two methods overloaded, the one of them having the milliseconds and the other one having the millis and the nanos. And you can use any of them, but usually if you'd actually use one of them, most probably it will be the one with millis. I've actually never seen in a real world scenario the one with the nanoseconds used, because nanoseconds are quite small, and still when you have a delay of your JVM is now still in milliseconds, so it doesn't make a lot of sense to refer to so much precision from my point of view. So that's why probably in most of the cases the milliseconds one is used in this case. That one is a timeout. The number of milliseconds means if the thread didn't finish didn't finish its task and this time passed, then it will actually throw interrupted exception and the execution might continue. So you can use it to decide whether you want not to wait forever for a specific thread to get finished, but you want to only wait for a defined time. Well, in my case here, I don't have a lot to prove with that milliseconds one, but I will use the one with no parameters. In all of the cases anyway, join method specifies that the current thread waits after the one from which we referred to the method. So in my case, it says the main thread should join T1, that is, the main thread should wait for T1 to finish before continuing. And again, you see that I have a compilation problem. And as I specified just a few minutes ago, always remember the rule of thumb, always when having a method that's blocking threads, it throws that checked exception named, you see it now here, interrupted exception. So like in the case of sleep, you have to actually add the try catch, or yeah, I could actually thrown it out from the main, but it's not really okay to throw exceptions out of the main method. So that's why I will choose to simply add a try catch here. So I've treated it now, and the same thing I need to do for T2. So T2 join, that means, well, in my case, it doesn't matter in which order I do call them, because in any case, my current thread really needs to wait for both of them in order to continue. So that's, in my case now, main will not go past these two lines if T1 and T2 didn't finish. So if I run my example here, you will actually see now that processing is not displayed first, and it will actually be always after both of db1 and db2 have been queried. So another question, by using which data structure Java thread concept implemented? I honestly don't understand. What do you mean by using which data structure? Do you actually refer to a collection? So do you refer to which collections are concurrent, like for example copy on write array list or copy on write array set, concurrent hash map, or do you refer to something else? So please clarify this, because I don't understand what your question is. If it's about the concurrent collections, I have a separate lesson, or maybe even a couple of lessons in which I will discuss them. It's not a 5-minute subject, so I prefer to leave it for a separate lesson and discuss it in details. So if it's about concurrent collections, you will actually learn that all together with the about 7 or 8 basic implementations of concurrent collections. There are about 7 or 8 implementations, and that will be in a few lessons from now on. If it's something else, then please clarify it so I do understand what do you mean by that. Either stack or queue. Both stack and queue, they are interfaces, and they might be implemented by concurrent implementations or by non-concurrent implementations. So it doesn't really matter, you choose stack or queue based on what you need to implement, and also based on what you need to implement, you will choose either a concurrent implementation or you will choose a non-concurrent one, and you will do the synchronization yourself. If my answer wasn't clear, then just wait for me to complete all the thread series, and you will understand. If you have some experience already with that, you might understand what I have tried to explain you. But if not, then you will find it out throughout the lessons. So stack and queue, both of them represent contracts to interfaces, contracts to collections, and might be used with threads. Both of them, you don't choose them based on threads, but you rather choose them based on your algorithms or what you'd like to implement. And then whichever implementation of stack and queue you choose, it really depends on how you are working with that. If you say work it on different threads, you might take the decision to use a already concurrent implementation. That means one of the implementations provided by Java in the Java util concurrent package that's already it's already dealing with the threads. Or you might choose to use a non-concurrent one like the array deck, and then you will actually have to do the synchronization yourself. So I hope this clarifies at least a little bit your question, but if not, no worries. I will deal with all the details related to threads, and we will have plenty of lessons about threads, same as we had about Stream API. So you really want to stay on and follow them, because you will learn a lot of things about threads and multi-thread architectures. I promise you, I did actually work with this in real world scenarios, even though they are it might happen that you will not even encounter them as a developer. I was actually lucky to work and develop my own multi-thread architectures some time ago, and that's why I say I actually have some experience with them, some practical experience. So I don't only discuss these subjects out of the books, and you will find a lot out of from my experience that might help you, or at least will help you in case you will have to implement multi-thread architecture. And if you will not have to implement multi-thread architecture, it still at least open your mind on how multi-threading works. So I hope this will really help you with development in general. Going back now, so that we can actually end our example. You see here that indeed processing was the last one, and now I promise you how many times I would actually run this, it will always be the last processing. DB1 and DB2, even if I have different times, I can't bet they will never be the other way around. I can't bet that in absolutely all the situations, 2 will be first and 1 will be the second. Because they are still different threads running in parallel. And yes, I know, being that I have a second difference, most probably they will always be like that, but in general, you never bet on that. But processing, I'm sure that processing, the message will always be displayed the last one, because of the join, because that's the purpose of join. It's again our first synchronization we are doing, which in this case actually represents a thread waiting for another thread to finish. And one of the things you might encounter even in real world scenarios, and one of the things again which is of course also part of the OCP 11 exam questions, OCP in general exam questions. So that being said, because we have so less time left and we don't have time for another useful example, I would like to actually conclude here, and I would like to tell you actually what we'll be doing for the next lesson, where we continue with the threads. So we will continue our discussion basically with synchronization, and in the next lesson I will implement from scratch, so from zero, an example of consumer-producer architecture. The consumer-producer architecture is basically one of the most fundamental multi-threaded architectures, and you will find it useful actually even in real-world scenarios, even if it's probably the most basic out of the multi-thread architectures. I will give you some examples where you might use that, but that's not only important about it, is also that we will use that kind of architecture to prove how the synchronized method works, and I will show you some syntaxes about the synchronized method and how it works, and the synchronized keyword, sorry for that, the synchronized keyword and how that works, and you will learn how to synchronize blocks of instructions using the synchronized keyword, which is not only again part of the OCP exam, but it's also a very important thing to know for any real world scenario. That's it for today, and thank you very much. Oh, I see I have a question here. Can you recommend a book on threads? Let me actually take a look, because I didn't read a book on threads for about more than 5 or 6 years. So to answer your question properly, allow me just to do a little bit of research and try to at least look through the summary of some books and see if I find one that is actually more recent than the ones I know now. Otherwise, if I would recommend you one from 5 years ago, it might be that's not the best to read right now. You see, these things, even if things related to architectures don't change that much as frameworks. They still change pretty fast, and I'm not even sure if I know a book that touches Java 9 and above with threads. So let me do some research and I will try to answer your question about a book related to threads. If no other questions out there, and I don't see other questions, then thank you again very much for attending and have a great time for study.